Now we move on to the next sum in the Ncert book, the sum where three girls are sitting in a circle and the girl called Reshma is throwing a ball to Salma and Salma is throwing to Mandeep. I have not written the entire question, it's a long one, but you know the crux of the question. The distance between Reshma to Salma and Salma to Mandeep is 6 meters each. You need to find the distance between Reshma to Mandeep. Now, since they are sitting around in a circle, so our first step would be to draw a circle with a center. Reshma, Salma, Mandeep. Any solution for this particular sum, if you check online or if you check in any of the reference book, you can see that the points where these three people are placed are always on one side of the center. I am not aware of the solutions that are being given to you in your classrooms, but I am asking you, why can't I place these three girls at different points in the circle? Like this, all around the center, like this. This is 6 and this is 6. Why can't it be something like this? Now, whenever you are drawing a diagram, you should know what is the reason for that particular diagram and why the diagram cannot be drawn in a different way. Now, that is always the crux of understanding a sum in geometry, especially when you are dealing with any of the diagram like this, or when you are dealing with angles or a particular sector or a circle or a quadrilateral placed inside a circle, anything for that matter. You should know why the diagram happens and why exactly it has to be drawn in exactly the same way. So now let us see why we cannot place these three people all across the circle. Okay, in this particular sum, that you can see that Salma is the person who is common to both of them, or Salma has to be the midpoint because the ball is going from Reshma to Salma, Salma to Mandeep, and these two are given to be 6 meters. So we know that whenever we are going to join those points, we are going to get at least an isosceles triangle, maybe an equilateral, but we know for sure it is an isosceles triangle. So before I move on to this particular sum, let me give you an idea about an isosceles triangle inscribed in a circle. Now you got the basic idea that you are talking about a circumcircle, right? And we have a circumradius and there is going to be a circumcenter. Now, this is a circle and I am going to draw an isosceles triangle. Okay, a random isosceles triangle I am going to draw. In this case, my center or the center of the circle or the circumcenter is inside the triangle. This side and this side are equal, A, B, C. Fine. Now, if I am going to drop a perpendicular bisector from A to this base, or let me say I am going to drop an angle bisector, not a perpendicular bisector, an angle bisector. This angle is x and this angle is x. Okay. Now, these two triangles, you can say that they are congruent. SAS congruence. AB is equal to AC. AD is a common side. This angle and this angle are equal by construction. Angle bisector. These two triangles are congruent. Because of that, I can say that this angle and this angle are equal. Okay. This side and this side are equal. Corresponding parts of congruent triangles. Now, the sum of these angles will give me a 180 degree. So, each angle has to be a 90. So, this angle bisector automatically became the perpendicular bisector also. But then this is a concept that you should know already. For an isosceles triangle, perpendicular bisector and the angle bisector will remain the same when it is drawn to the third side. Okay. Now, BC is a chord of a circle. You know that the perpendicular bisector of a chord always passes through the center of the circle. So, my center is not here. It is somewhere along this perpendicular bisector itself. So, for an isosceles triangle, you know that the perpendicular bisector to the third side will always automatically pass through the center or the circumcenter of the circumcircle. You understood this concept? Now, let us get back to the sum. Now, have a look at this particular diagram. AB and AC. This is Salma. This is M. Okay, Reshma, Salma and Mandeep. Now, I am going to place them in such a way that BC is my diameter. I am going to place them in a very ideal way. You know that in a circle, from a given point, if this is the diameter, this is small, this is longer and this will be longer. Correct? So, as and when you approach the diameter, the height of the chord or the length of the chord will automatically increase. Now, this is 5 and this is 5. This is a 90 degree because this is a perpendicular bisector which is passing through the center. So if this is 5 and this is 5, what can you say about the hypotenuse? You can say that the hypotenuse has to be 5 root 2. You know that 5 root 2 is a value which is greater than 6. So my this side cannot reach the diameter. It has to lie a little above the diameter. Hence, my diagram would be this is my diameter. This is how the girls would be placed. Now, did you get the reason why these 3 people were placed on one side of the center and not all over the circle? So, depending upon the distance between the girls, the diagram has to be drawn. Suppose it was a length which was greater than 7 or an 8, then automatically the center would fall inside the circle. Okay? You can see that I have redrawn the entire diagram. So, Reshma, Salma and Mandeep, this is 6 and this is 6 and this is the center of a circle. The perpendicular from the center will automatically pass through the vertex and become its angle bisector also because it is an isosceles triangle. Now, I will mark this point as P. Okay. What is this distance equal to? This is 5 because it is a radius of the circle. What can you say about OS? OS is also the radius. I can say that is also equal to 5 meter. OM is also equal to radius. That is also equal to 5 meters. Fine. Now I need to find the distance RM. This is our question. You can see that RM is bisected at this particular point. So this is X. This is X. I need to find the value of X. I have a right angle triangle over here which is SPM. Fine. I have another right angle triangle over here, OPM. So let us see whether we can apply the Pythagoras theorem and solve. Okay. In this diagram, you can see that OS is equal to 5. But one vertex of the triangle is P, which means that this distance and this distance are important to us. The total distance is 5. So if I am calling this distance, which is OP is equal to Y, what can I say about PS? PS is equal to 5 minus Y. Right? Now let us apply the Pythagoras theorem. So from the triangle SPM, applying Pythagoras theorem, I have got 6 square is equal to x square plus 5 minus y the whole square. And from the triangle OPM, I have got x square plus y square is equal to 25. Now I will open the bracket for the first one and using both the equations, I will try to solve for x as well as y. So I have opened the brackets over here. You can see that this is expansion of 5 minus y the whole square. So I have grouped x square and y square. The remaining terms are here. From the second equation, you know x square plus y square is equal to 25. I have substituted it over here. And I am getting the value of y as 1.4. Since I am getting the value of y as 1.4, I can find the value of x by substituting it in x square plus y square is equal to 25. After finding the value of x, you have to multiply it by 2 because x is only half of the length in order to get the entire length Rm. Before we move on to the next sum, let me ask you a question. Suppose these 3 girls were placed at a distance of 15 meters in a 10-meter radius circle. How will you draw the diagram? I explained to you why the 3 points were placed on one side of the center, and I am hoping that you have understood it. So I am asking you a question. Suppose in the question paper you receive a question like 3 girls are placed at a distance of 15 meters each is the distance between Reshma to Salma and Salma to Mandeep. You need to find the distance between Reshma and Mandeep, and the circle is a 10-meter radius circle. How will you be placing the diagram? So the girls are at a distance of 15 meters each. I told you in a circle, if this is the diameter with O as a center and this is 10 and this is 10, this side will be 10 root 2 because 90. Okay. 15 meters is greater than 10 root 2. 10 root 2 will be around 14.14. 15 meters is greater than 10 root 2. So that particular line will fall under the diameter. So the girls are placed in this way. This and this. So when you get a triangle like that, what is the difference that will make to the sum? That it will make to the sum. Draw the diagram and see how the equation will turn out to be. You will be surprised to see that you will be getting a different equation. Again, you will be getting a quadratic equation, but then instead of a minus sign, you will be getting a plus sign. I want you to try it out and then tell me what is the answer that you are getting. So, okay, so now we are done with that particular sum. One kuti sum we spent so much of time explaining that one sum. The reason is because the circumcircle or the circumcenter of an isosceles triangle may either fall inside the triangle or may fall outside the triangle, depending upon the circle radius and the sides of the triangle. But fortunately, with an equilateral triangle, there is no such issues. The circumcenter will always fall inside the equilateral triangle. Now, the next sum, I think three boys are sitting in a circle. That sum, which defines an equilateral triangle. Before we move on to that sum, I want you to understand a particular concept, because that is a concept that we are going to use in that particular sum. Now, you can also by heart the concept. I am telling it to you because not everyone has a passion for understanding what they are doing. Some of them just by heart a few concepts here and there and then apply it to the sum. Now it is left to you whether you want to just learn the statement and then put it in the sum. Now, but anyway, I will explain why exactly we are using that concept. You can go through the concept or you can just fast forward the video and take only the concept and apply it on the numerical. Okay. You can see an equilateral triangle which is inscribed in a circle. So AB is equal to BC is equal to AC. We are doing this particular proof in order to show that the centroid of the triangle is also the circumcenter of the equilateral triangle. Now, and also to show that the circumcenter falls inside the triangle, because the centroid of an equilateral triangle is always inside the triangle. Now, what do you mean by the centroid? Centroid is the meeting point of the medians. Now, what are medians? Medians are lines drawn from the opposite vertex to a side of the triangle in order to bisect it. Now, for an equilateral triangle, you know that the median, the altitude and the angle bisector all become the same line only. So, here, if you are drawing these are the median. So, this point is called as a centroid. Okay. When I am saying this is the median, what can you say about, let me call it as X, Y and Z. I can say that AX is equal to CY, BX is equal to CX and AZ is equal to BZ. All these parts are equal to each other because they are the medians. Now, these three medians pass through the point G. We need to show that G and the center of the circumcircle are the same points. Now, let us take congruence in order to show this. Let us take the triangles BYC and the congruence of CZB. Okay, BC is a common side. So, as you can see, BC is a common side. CY is equal to BZ because AB and AC are equal because they are the sides of an equilateral triangle, and at this point they are bisected. So, CY is equal to BZ. Each angle of an equilateral triangle is a 60 degree. So, angle B is equal to angle C. So, the triangles that we have chosen, they are congruent by means of SIS congruence. So, since we have proved the triangles are congruent, I can say that the side BY is equal to CZ, corresponding parts of congruent triangles. Similarly, if we take the triangles AXC and AZC, basically the same congruence when you apply, you write down the steps, you people write down the steps, you can see that AX is equal to CZ. So, from these two congruences, I can say that all three medians of an equilateral triangle are equal. So, I will get AX is equal to BY is equal to CZ from here and from here. So, we will be continuing with the proof, but now you know how to prove that the medians of an equilateral triangle are equal. Basic congruence, always we keep taking congruence. Okay. Now, These three lines are equal. If I am multiplying with a 2 by 3, what do I get? 2 by 3 ax is equal to 2 by 3 by is equal to 2 by 3 cz. Why am I taking 2 by 3? I am taking 2 by 3 because this particular point G, which is a centroid, is dividing every single median in the ratio 2:1. So this is 2 part, this is 1 part, this is 2 part, this is 1 part, this is 2 part, this is 1 part. So out of the 3 parts from the vertex, this is the 2 out of 3 part. Similarly from here and similarly from here, what we are basically getting 2 by 3 ax, 2 by 3 by, 2 by 3 cz, which means that this particular point G is equidistant from all of the 3 vertices. Now, do you remember the basic definition of a circumcenter? It is a point which is equidistant from all the vertices of the inscribed triangle. So, I can say that the centroid G and the center of the circumcircle are basically, they coincide with each other. You cannot say they are the same point, technically not correct, they coincide. Okay, we took just basic congruences of the triangles in order to show that the medians are equal. You multiplied all the medians with the 2 by 3, then you got the centroid, because centroid divides each of the medians in the ratio 2:1. Now, this proof is something that you don't really need to study, you just need to understand. Okay, if you are not interested in understanding, I told you, you just need to understand that centroid and the circumcenter coincide in an equilateral triangle, and that centroid is at a distance of 2 by 3, or the centroid divides each median in the ratio 2:1. Please understand these 2 points and move on to the last sum in the exercise 10.4. Okay, so in the last sum, there is a park in which there is a circular park of 20-meter radius, and 3 boys, I think Ankur, Said and David, they are sitting on the circumference of the park having a toy telephone. Now they are sitting in positions which are equidistant from each other. So we know that when we are drawing and then joining the points, we will get an equilateral triangle. See, the reason is this arc is said to be equal to this arc, is said to be this arc equal to this arc. So when we know that equal arcs subtend equal chords. So this is an equilateral triangle, and you know that for an equilateral triangle, the center falls inside, the circumcenter falls inside the equilateral triangle, and the median will be here. The median will coincide at the point G, which is also the circumcenter. Okay, what am I telling? Fine. Now, you know that the radius is 20 meters. So, I am putting the boys at the points A, B and C. So, I know OA is equal to OB is equal to OC is equal to 20 meters. It is given in the question. Now, OA is 2/3 of X, Y, Z, AX. Fine. Now, 2 by 3 AX is equal to 20. So, what is the value of AX? 20 into 3 by 2, which is 30 meters. So, after getting AX as 30 meters, see, there are multiple ways of doing this. I have just written one method. You take the triangle AXC. You know that AXC will be a right angle triangle because the median will be at a 90° to the base. That is a property of an isosceles for an equilateral triangle, and also an isosceles triangle if you are taking the third side into consideration. So, if the length of AC, I am representing it as A, you know that BC is also A, AB is also A, but this part will be A by 2. So, A square plus A by 2 the whole square, A by 2 the whole square plus AX square will give you A square. Correct? Okay. I know the value of AX, which I have found out as 30 meters. So, 900 is equal to 3A square by 4. You will get the value of A square as 1200. Find out the value of A. You will get it as 20√3. Okay. Now, there is one more method of doing this. The length of BY is 30. But you know that OB, the length of OB is 20. This side, OX, the entire length was 30. This was 20. So, you know this is 10. So, if you apply Pythagoras theorem to this triangle also, you will get the length of BX. Multiply it by 2 in order to get the length of BC. Fine. So, we have completed almost all the sums in exercise 10.4. Two of the sums were based on the theorems of equal chords are equidistant, etc., etc. And I told you to study the example and those two sums together because they are related to each other. And now we learnt about circumcircle, the triangle inscribed is a circumcircle, and in one sum there was an isosceles triangle. I told you how to position the isosceles triangle with respect to the sides and the radius of the circle, and the equilateral triangle wherein the centroid will coincide with the circumcenter and the centroid is at a distance, or the circumcenter is at a distance of 2/3 of the center length. Okay, so I'm hoping that you guys will be able to apply all this concept into whichever type into whichever sum you are getting based on the same concepts.